In this video, you're going to learn about similar figures. So, two shapes or more are considered as similars when they are exactly in the same shape but different size. For example, these two figures, they are exactly in the same shape but different size. So they can consider as similar. Similar shapes have some features like the angles of the similar shape have to be equal in the side, and the side are in the same ratio. For example, the two rectangles, they have 4 right angles, which is 90 degrees. So they satisfy the first requirement. The second one, the corresponding sides are in the same ratio. So I have the length of this one over the length of this one is 1/2. The ratio of the width is width of this one over width of this one is 1/2. So they are in the same. They are same. So these two rectangles are similar figures. And same here with the right angle. The symbol of the similarity is this one. So, for example, you write this triangle ABC similar with triangle DEF, and remember when you write they have to be in order, in corresponding order. Angle A, the corresponding of A is D because A equal with D. The corresponding angle of B is E because B equal with E. So you write A, D, B, E, and the last one is C and F. To test two triangles are similar or not, we have some features to test it. The first one is the two triangles has corresponding angles are equal in side. A for angle. For example, these two angles, they have the corresponding angles are in the same side. C equals F, A equal D, and B equal E. Or the next one is the corresponding sides are in the same ratio. For example, with these two triangles, if AB over DE equal BC over EF equal AC over DF, then they are similar figures. The next one is two pairs of corresponding sides are in the same ratio, but the included angles are in the same side. So for example, this one, if you have AB over ED equal with BC over EF like this, then you have to consider the angle in between the two sides is angle B has to be equal with angle E. With the right angle triangle, so right angle RHS, I for right angle, yes, they are right angles, so they have this one. And the hypotenuse, the ratio of hypotenuse have to be equal with the ratio of one corresponding side. So for example, the ratio of hypotenuse is BC over ED, then it can be it has to be equal with AB over ED or equal with AC over DF. You just need one pair for this one pair for corresponding. Scale factor. Scale factor is telling us how many times the origin has enlarged to get the image. To calculate the scale factor, we use this formula. It's equal to the dimension of the image divided by the dimension of the origin. So if I have these two rectangles, how to tell if these two rectangles are similar or not? We're going to calculate the scale factors. If the scale or the ratio of the length over the ratio of the width, if they are the same, then they are similar figures. So the ratio of the length is 42 over 7, which is 6. The ratio of the width is 18 over 3, which is 6. So they both equal 6. So I can conclude they are similar figures. And the scale factor is 6. To calculate the scale factor, I'm going to get the dimension of the image over the dimension of the origin. So 42 divided by 7 is 6. What is the area scale factor? To find the area scale factor, we find the area of B and divide it by the area of A. We will get it is 36. And 36 is 6 square. And 6 square here is this one. So there is a relation. And how related is it? We're going to check for the next, in the next slide. I have 3 cubes, cube A, cube B, and cube C. Cube A is the origin, cube B is the image, and C as well is the image. To find the scale factor of from A to B, I'm going to get the dimension of the image, which is 4, and divided by the dimension of the origin, which is 2. So I get the scale factor is 2. And the scale factor of the volume, I'm going to get volume of this one, which is 64, divided by volume of this one, which is 8. So it's equal 8. And 8 here is 2 to the power 3 is equal the scale factor of the side length cube. So if you have the dimension of the origin and the scale factor to find the dimension of the image, or the other way around, how can we do it? We're going to use the formulas to find the dimension of the enlarged image. We're gonna get the dimension of the origin times with the scale factor. To find the area or surface area of the enlarged or the reduction of the enlarged, we're gonna get the area of the origin times with the scale factor divided by scale factor square. If you want to find the reduction, the smaller shape, we're gonna get the origin divided by the scale factor square. And same with the volume. The volume of the enlarged one will equal the volume of the origin divided times with the scale factor cube. Example of similar triangles. I have the 2 triangles are similar, and you have to find x. I know that the 2 triangles are similar. They're going to have their side length, the corresponding size ratio going to be the same. So it means x over 24 equal 4 over 12. Then here I use cross multiplication method to find x. X will equal 4 times 24 divided by 12, which is 8 centimeters. What is the scale factor? To find the scale factor, is equal the dimension of the image, which is 12, divided by the dimension of the origin, which is 4, and it's equal 3. There's some other example of the similar solids. For example, this one is the cupboard. This one is the origin. This one is the image. And then you can see here, to know if these 2 are similar or not, we're going to get the ratio of the length over the length, and the ratio of the width, and the ratio of the height, to see if they are exactly the same or not. And I did it, and I found they are exactly the same. They all equal 3. So these 2 are similar figures. Same here with the cylinders. With the cylinder, for example, if this one is the origin, this one is the image, and to conclude if they are similar or not, I'm going to find the ratio of the height, which is 6 over 3, which is 2, and the ratio of the radius, which is 2 over 1, equal 2 as well. So they are equal to, they both equal to. So this one are the similar figures. So in this one, if I have the volume of, this one is the origin, and this one is the image. If I have the volume of the origin, how can I find the volume of the image? From here, you can calculate the scale factor. Then, and this one from origin to the image, you reduce. So the volume of the reduced image equal the volume of the origin divided by the scale factor, which is 2 cube. Okay, so if you find the enlarged one, you're going to times with the scale factor. But if you find the reduction, you have to divide it by the scale factor and cube. Same here with the cones. So to conclude if these 2 cones are similar or not, we're going to find the ratio of the height, 20 over 5 is 4, and the ratio of the radius is 6 over 1.5, which is 4 as well. So they both equal 4. So we can say that these 2 figures are similar.